Okay. Good afternoon, all of you. Is my voice clear?
Yes, sir.
So no one is responding. Why? What is the reason? ఇలానే ఉంటుంది ఫస్ట్లా ఎగ్జామ్ రాసేటప్పుడు తెలుస్తుంది, ఎవరికి అర్థమైతలేదు నేను చెప్పేది. సరే, వాట్ ఎవర్ మేబీ. సో we have completed the VI characteristics of SCR, that is a thyristor. Now what you have to learn is general thyristor ratings, that is important ratings of thyristor family devices. So in the thyristor family devices, we have for any device, not only thyristor, even any electronic component or gadget you have purchased in the market, it should have some ratings or specifications. Okay, so while purchasing the component or a device, you should aware of these specifications or ratings. If you are not aware of that ratings, what will happen? If you operate in the different range of component values, then it will be specified values or component values. It will be burnt or damaged. Something it will be happen. So that is the reason you have to aware of these ratings or specifications. So first one is what type of specification we have is anode voltage ratings. So anode voltage VA, so it should be in the range of volts or kilovolts. In the current rating, what is the current ratings? What is the power rating? What is the turn on time and what is the turn off time? What is latching current? What is holding current? What is the rating of latching current and holding current? It is in the order of milliamperes. Now what is the dV by dt rating? What is the di by dt rating? So what is the temperature ratings? So these are the some thyristor ratings. You should aware of this. So for that case, you have to learn about what is the definition of these ratings values as well as the definitions. Okay. So first one is the anode voltage rating. What is the it means? What is it means? So it indicates the maximum voltage that can be applied across the device without causing any breakdown at junction area. That means if you are applying any voltage which is below the anode voltage rating, the maximum anode voltage rating, then it will be safe. If you are beyond that anode voltage maximum specified voltage rating, it will be breakdown. That will be breakdown. The junction will break down, so it will cause the enormous current in the device that will be happen to burnt. It will be completely damaged. So that is the reason you have to specify a maximum anode voltage rating. So what is the meaning of anode voltage rating? Means it will indicates the maximum voltage that can be applied across the device without causing any breakdown at a junction area. Okay, next one is current rating. So what is the current rating? Means there are different current ratings established with respect to non-repetitive waveforms. Okay, and the current should not rise the thyristor junction temperature even for short overloads of current. Okay, if the junction temperature increases rapidly, the thyristor will be damaged. Hence, the operating current should be within the limits for the safe working of the device. Is it clear? So current rating also tells us that what is the maximum current it can be withstand. What is the maximum current it can be capable of withstand. So if you are beyond that limits, it will limits. It will not in the safe limits. It will not be in the safe limits. Okay. So current rating also specify the maximum current rating that will be established during thyristor junction temperature to increase even for short overloads of current. Okay. So next one we have a turn on time. What is the turn on time? Is the time taken by the thyristor to reach full conduction. So what is the thyristor to reach the full conduction? You can call as a turn on time. That is the turn on time T on is depends on the two parameters, delay time as well as rise time, TD plus TR. Okay. So what is the TD? This is the TD. This is the TR. So it is the what is the time taken for a pulse or a thyristor to reach its maximum value. This is the maximum value. How much time it will take to reach its full conduction or reach its maximum value. You can call as a turn on time. T on is equal to delay time plus rise time. So this is the delay time. How much time it will take to reach this value? You can call delay, and how much time taken to raise for this maximum peak? You can call as a TR. So what is that? Turn on time is T on is equal to delay time plus rise time. TD plus TR. Okay. Next one is turn off time. So what is the turn off time? Is how much time for a thyristor to from zero current point to when the thyristor again regains its blocking voltage is called a turn off time. Okay, so turn off time is reverse recovery time plus combination time. So T off is TRR plus TR, reverse recovery time plus recombination time. Okay, so it is turn off time is also depends on the two parameters, reverse recovery time TRR plus recombination time TR. Okay, so T off is equal to TRR plus TR. Okay, so what is the turn off time to? Turn off time is how much time taken from its maximum value to its zero value. It's regain its original value, regain its original value. That is from the maximum to regains its original value or original state where it is start. Okay, so that is state you can call, you can the how much time it will take and from maximum peak value to the its regains its original value or a zero state. Here is zero state, so in zero state you can call as a what is that turn off time. So turn off time is TRR plus TR. Okay, so you can draw this diagrams, you can easily understood what is the turn on and turn off time. Turn on time is depends on the delay time as well as rise time, whereas turn off time is depends on the TRR plus TR, reverse recovery time plus and recombination time. Okay, so what is the dv by dt rating is? So these are two are important, both are important and they are exclusively for a thyristor only, not for a your diode or a transistor. You will not represent this dv by dt rating and di by dt rating. It will be only present for a thyristor or SCR. Okay, so it indicates dv by dt rating is indicates the what is the maximum rate of rise of voltage from anode to cathode without any harm of the device. So what is the meaning here? It is dv by dt. Within a short span, how much voltage it will be raised to anode to cathode voltage. That rating you can call as a dv by dt rating. That means within a short span, how much voltage it is raised rise of voltage from anode to cathode. Okay. So and di by dt also same thing. It is a maximum rate of rise of current from anode to cathode without any harm of the device. So what is the short span? How much voltage you can maximum it can be withstand with a short span? Within a short span, how much maximum rate of voltage it will be? It will be safe. It will be safe. That will be indicated by dv by dt. What is the maximum rate of rise of current? It can be withstand. We can call as a di by dt rating. Okay, so these are six specifications you can have. 1 2 3 4 5 6 ratings are there, so they are important. There are also some they have some temperature ratings also there, so you can see in this tabular form the important ratings of SCR. So what are they? Within the you should operate the SCR in the within the safe limits. What are the safe limits means you can see here. So what is that? They are given the specifications for these devices. What is that? C20D, C22D, C220D type SCRs. Okay, so they are the three types of SCRs we have, and the ratings are also given. They are specified ratings. They are the specified safe limits of SCR. Okay, so what is that voltage ratings are? What are the voltage ratings? Forward breakover voltage, on state voltage, and firing voltage, and the voltage safety factor. And right, dv by dt, this is di by dt. So what are the voltage rating means? These are the voltage ratings. So these all comes under voltage ratings. These all are comes from the current ratings. Okay. So voltage ratings are, what are the voltage ratings? Forward breakover voltage, how much you should be there? 50 to 1200 volts. The safe limits is 50 to 1200 volts. Depends on the different types of thyristor. Either it may be C20D, it may be a C22D, it may be a C220D. Okay. And the on state voltage V on is 1 to 1.5 volt. We already discussed this. In the forward conduction mode, the thyristor will be on state, and the voltage drop across the thyristor is about to 1 to 1.5 volts or 2 volts maximum. What is the firing voltage? How much voltage? That means gate voltage you can call as. Firing means gate pulse voltage. So more than 4 volts you have to given. So voltage safety factor, it is 2 to 2.7, and the dV by dt rating is, you can, it will depends on the dt. Dt means a small span. How much time you can take, it will have the how much voltage it will be raised. So it will be dV by dt means it is 10 volts per millisecond. Okay, 10 volts per millisecond. Write down in this fifth column. It is 10 volts per millisecond. Okay. Next, peak inverse voltage. Peak inverse voltage, it is in the order of same as that of your anode voltage. Forward breakover voltage, it is 50 to 200 volts. So here 50 to 200 volts. Here rise voltage is 10 volts per millisecond. 10 volts per millisecond. You have to write down here these columns. Okay. Next, you have a current ratings. Latching current. Latching current is in the order of milliamperes. We have already discussed 5 to 10 milliamperes. Here, depending on the device, it is 8 to 10 milliamperes. So holding current is 3 to 5 milliampere. We already discussed IL is greater than IH. So latching current always greater than the holding current. That is, it is 8 to 10 milliamperes IL. Holding current is IH is about 3 to 5 milliamperes only. So gate current is 11 milliamperes to 18 milliamperes. A rate of rise of current di by dt is 300 amperes per microseconds. Okay, it will have a 3 di by dt rating is 300 amperes per microseconds. Gate loss, it should be in the only in the order of milliwatts. Very small power ratings or power dissipation. And turn on time is 2 to 10 microseconds. Turn off time is 50 to 200 microseconds. That means the turn off time is more, T off is more compared to the T on. Very important, it is also the turn on time is very quick. The turn on time is very quick because gate voltage or gate current is very high, whereas turn off time is very high, delay is more. Turn on time, it will quickly on. The thyristor will on quickly, but the thyristor will off itself very slowly. That means it is in the order of 50 to 200 microseconds. That means you can see 5 times, almost 5 times, and more than 5 times it is there in the turn off time. Okay. So you have to remember turn off time is more compared to the turn on time. Evara Kiran evara video off cheyamani. Next, so some other definitions also there. So these are also very important. These important definitions you can see here. So what is a forward breakover voltage and latching current, holding current, turn on time and turn off time. So they will also ask in the number of times they will ask this. So number of times they will also ask in the question paper, what is the forward breakover voltage, what is latching current, what is the holding current. Okay, so something they will ask. What is the 3 marks question they will ask. So write down what is the forward breakover voltage in your notes. Important. So here it is the voltage. It is the voltage at which SCR is switched off from its off position to on position. Its value is maximum for IC equal to 0, and commercially available SCRs have VFBO ranging from 50 to 1200 volts. We already discussed VFBO or VBO. It both are same, forward breakover voltage, or simply you can also call breakover voltage. So VBO or VFBO are both are same. What is the meaning of forward breakover voltage? Which it is the voltage at which the SCR is switched off from its off state to on state. Okay. So already we have seen in the characteristics, SCR characteristics, if you see, so VFBO is present here. Where here? So VFBO or VBO is present here. After reaching this value, the SCR is comes into start or conduction. Okay. So what is the voltage? What is the voltage? What is the voltage you have? What is the voltage at which the SCR is switched from its off position to on position? You can call it as a breakover voltage. For Ig equal to 0 without gate current, it has the maximum forward breakover voltage. The Ig is increases, breakover voltage will decrease. The Ig is increases, breakover voltage will decrease. That means if you are increasing the gate current or gate voltage, the breakover voltage will decrease. And the ratings of the VFPO is from 50 to 200 volts. Okay. So this is the forward breakover voltage. Next one is the latching current, IL. So what is the latching current is already discussed. It is the minimum value of current which is required to latch the device from its off state to on state. So latching current is depends on the its turn on time, already discussed. Okay. It can also be defined as the minimum value of current required to trigger the device. Its value is normally in the milliamperes. What is the value? 5 to 10 milliamperes. Okay. It is the value of current at which the required to latch the device. Latch means turn on, latching the device from its off state to on state. And it also can be defined as the minimum value of current required to trigger. Trigger means on, trigger the device. Its value is normally in the milliamperes range. Okay, so IL is here. The characteristics, if you see, that is the reason characteristics are most important. The characteristics are most important here. Latching current, this is the latching current. So actually before latching current it is in the off state. Off state, this is the off state, forward blocking mode. Okay, so this is the off state. On reaching this value latching current IL, it is getting on. The thyristor is on or SCR is on. So that is the reason the latching current is used as in order to latch the device. Latch the device in order to from off switch to on. It is turn on, it will turn on. Okay, holding current is represents its turn off time. The parameter depends related to turn off time. What is the holding current mean? It is the value of anode current below which the SCR switches from its on position to off position. Okay, so below it is above. You have to remember these words. From latching current is above which off state to on state. Here below which it is on state to off state. Okay, so there is the value of anode current below which the SCR switches from its on position to off position. Under given conditions, always IH is less than the IL. That is latching current. That means IL is greater than IH. The latching current of the particular thyristor is in the range of 8 to 10 milliamperes. Then the holding current is only about 3 to 5 milliampere. We already see the ratings. Okay. So holding current always turn off time. Turn off time. Latching current always relates to turn on time. Okay. So what is the turn on time? We already discussed. What is the turn on time? How much time taken from the device to conduct? Correct or not? Simple definition is this. So how much time to take it to conduct the device is called as a turn on time. Okay, or response time. You can also call turn on time. You can also call response time. What is that? The time for which the device waits for achieving its full conduction is known as a turn on time or response time. They also can be defined as the time taken by the device before getting latched from its off state to on state. The usual value of T on is lies between 2 to 10 microseconds. Okay, turn on time is T on or response time is what is that? How much time taken the device to turn on fully or conduct fully or on the device to on. So that time we can call as a turn on time. So and it is ranging from 2 to 10 microseconds. So what is the turn off time? The time taken to off the device. Correct or not? Simple definition. Switching from on to off. Okay. So a reverse voltage is required to be applied across the device for switching it off. After applying the reverse voltage, a finite time taken T off to get switched off commutated, then its value is around 200 microseconds. We have already discussed this. So how much time taken to turn off the device? You can call as the turn off time. How much time taken for the device to off? This can called as a turn off time, and it is the range of 200 microseconds, 50 to 200 microseconds, and it is more. Turn off time is more compared to the turn on time. T off is greater than T on. Okay, this is the definition, important ratings and important definitions of SCR or any thyristor family device. Okay, so we are talking about the SCR means you are also discussing the main parameters of the other thyristor family members also. Okay, so latching current is also present for other devices, holding current is also for other devices, and you can also have a 1 node voltage, cathode voltage, current rating, dv by dt rating, and voltage ratings, dv by dt and di by dt ratings, like this. Okay, so you are discussing means you are discussing the all devices at a time, because they all important parameters will present for all devices like diac, triac, as well as the your SUS, SBS, UJT, like this. Okay, so you have these definitions. You have to thorough with these definitions as well as the diagrams. Okay, important ratings also you have to remember. So what is the latching current? What is the holding current? Everything. So next we have differentiation between ICS, SBS, SCS, and LASCR. So you have to compare these devices. They will ask in the question paper directly what is the differences between the SUS, SBS, SCS, and LASCR. What is SUS? Tell me one. What is SUS? What is the SUS?
Silicon
Silicon
unilateral
unilateral switch.
Huh? Silicon.
Silicon unilateral switch.
Yeah, very good. Next, SBS. What is SBS?
Silicon bilateral switch.
Bilateral switch. What is SCS?
silicon control switch.
Silicon control switch. Very good. Next, LASCR.
Light activated SCR.
SCR, light activated silicon control rectifier. Right, very good. So these all also available in the IC forms. If you see in the first point, so SUS is available in the IC form, SBS also available in the IC form, SCS, LASC are also available in the IC forms. Okay, so it is a 4-layer device. SCS, LASC are also 4-layer device, because SCR are also 4-layer device. So LASC are also 4-layer device. So if you, how many terminals for the SUS you can have? 2 terminal or 3 terminal device?
3.
SUS is 3 terminal device. If you see the symbols, you can easily identify. What are they? What are the three terminals?
Anode, cathode, gate.
Anode, cathode, gate. You can also have MT1, MT2. Yeah, anode, cathode. In the place of anode, cathode, you can also replace MT1 and MT2. Okay, there is no problem. SBS also, how many terminal device?
3 terminal.
It is also 3 terminal device. Okay, next, what is SCS? SCS is how many terminal device?
4 terminals.
Terminal device.
This is the four terminal device, because 2 gates are present, anode gate as well as cathode gate. These are the different between the other device. Okay, LASCR you can same as that of SCR. So how many terminal device? It is 3 terminal device. It is also 3 terminal device. Next, what is how it will you see us, whether it is a unidirectional switch or bidirectional switch? It is a unidirectional switch or unilateral switch or unidirectional. Lateral means directional. So unilateral switch. It is also a unilateral switch. SBS is bidirectional switch. That means the current will conduct in both ways. That means anode to cathode, cathode to anode. Both ways it will conduct. Whereas SCS or SCR or all other devices, it will conduct only in the forward direction. Reverse direction, there is no current. There is no flow of current. That is the reason they are acts as a rectifiers. So what is the specialty of SBS is it will conduct in both directions. So that is the reason you can call as a bidirectional switch. You can call as a bidirectional switch. Others are, all other devices are unidirectional switch. That means they all are rectifiers compared to SBS. Okay, except SBS, all other devices are rectifiers because they will conduct in only one direction. Okay. Next, what is the speed of switching? Switching stability, which will have the more stable switching stability is What is that? Means SUS has high switching stability. SBS also having high switching stability. SES and LASCR have low switching stability. Okay. Next, what is the cost? Cost is high for a SES and LASCR. And the cost is low for your SUS and SBS. Okay. So because you have to apply a different terminal. SES have 4 terminal device. So that is the reason cost more. In LASCR you have to activate the light in the anode to gate. So that is the reason you have to perform external circuit. So that is the reason LASCR also have some cost requirement is more. So SUS SBS there is no requirement for other circuit or any specialty. So that is the reason they have the low cost. Okay. So it's about to only 10 minutes. We will wind up this differences and we will discuss in the next class. Okay. So this is the fifth point. Next sixth point is, so what are the having SUS characteristics? SUS characteristics like this. So if you seen in the previous class, we have characteristics also, symbols. In below the symbols we have characteristics. So SUS. So if you seen SUS, this is the characteristics. So how it will be SUS having characteristics means it's like a SCR only. Correct? SBS have characteristics is the same as mirror image of the first quadrant. Correct or not? The first quadrant characteristics of SCR is mirror image in the third quadrant because it will run in the both directions. That is the reason it have a, this is forward direction as well as the reverse direction also we have the same characteristics. In SCS we have like this. That means it is SCR only. SCS also perform like a SCR characteristics. Okay. LASCR also having the perform the characteristics as that of your LASCR is same as that of SCR. Okay. So what is the characteristics? Only SBS have the different characteristics. That means the forward characteristics and reverse characteristics both are mirror image. Whereas in the other cases, LASCR or SCS or SCS, these are all having the same characteristic as that of your SCR. Okay. So you can see it has positive turn on characteristic. It also have a positive turn on. They have positive turn off characteristic. They have a positive turn on characteristics. Okay. So you can also draw that characteristic curves here in the sixth point. There is no problem. Okay. So in the seventh point, you can see, so which one has the high speed of switching and where it is used. Most of the circuit applications, you can see, say that it is applications. Where it will use is SUS means high speed switching circuits or digital circuit pulse generators it will use. And the second one, what is SPS, you can use in the DC power supply, static variable resistors, and high speed switching circuits, digital circuits. In the applications of SCS, it is used in the low power digital circuits. And LASCR having HVDC. What is the HVDC? High voltage DC, electrical power transmission lines. HVDC are the DC power, DC transmission lines. In generally, we have a DC transmission lines, but in the case of electrical circuit, they are generated HVDC. HVDC, they are high voltage DC transmission lines. The static variable compensation systems also they will use. That means electrical systems they will also use. So they are the symbols we already seen. So 3 terminal. This is also 3 terminal. This is the anode, cathode, and gate. So 2 gates are there. One anode gate and cathode gate. And this is a light activated LASCR. Okay, LASCR. So these are the differences between the devices. Okay, so we will wind up here. So before that, we have to summarize this session. So what we have learned today. So what are the important parameters, important thyristor ratings? Tell me one. చెప్పండి ఎవరైనా. What are the important specifications or ratings of SCR or thyristor? రేటింగ్స్ చెప్పండి అమ్మా. Machpila, what are the important ratings? What are the annual voltage ratings? What are the current ratings? What are the other ratings? Annual voltage ratings means VFBO, forward breakover voltage. Turn on time, turn on voltage, V on. And what is the firing voltage? That comes under voltage rating. What are the current ratings? Latching current, holding current, di by dt rating. Okay, so they are the current ratings. What is other ratings means? Turn on time. What is the turn off time? What is the other junction temperature? Okay, so they are the other ratings. So this is the definitions. Also we have seen definitions. Okay, okay, we will conclude here. All of you see my video. Also I will post the video in your group. So all of you see my video and also share the video, because only 11 members are attend this session. This is not good. So please share that video also.